Welcome back to Smitty's Project. Steve here. This is part 2 of looking at can we power a Commodore 64 and a 12 volt LCD screen from a battery. But as you probably remember, I am also keen on getting the 9 volts AC to work so that even the Commodores that have a SID chip that needs the 9 volts AC will work unmodified. There's essentially 3 kinds of ways to generate an AC from DC. Well, 3 common ways. This cheap one here uses essentially a square wave that comes out of it. Then, stepping up a bit, this one is what's known as a modified sine wave inverter. And then the luxury one, which is a pure sine wave inverter. I'm going to show these on the oscilloscope. I suspect, or I really would like it to be a pure sine wave, as that's going to be the most successful, I would think, on the Commodore 64. But it's possible that we only need the modified sine wave. I suspect that it's not that critical because there is some rectifying anyway inside the Commodore to get it back up to 12 for the SID chip, things like that. So it'd be less noisy and more efficient as a pure sine wave. But we may be able to get away with a modified sine wave. As I don't currently have a battery, we'll just get a DC voltage out of this regulated power supply. So at 12.5, or technically I should be down at 12, I guess, but a normal car battery gets up to around 13.2, something like that. So 12.5 is not a problem. And I'll feed that into the first of our 3 inverters. This is the El Cheapo one that is supposed to put out a square wave. I suspect I've got a lemon one here, as I don't think anything's really happening. The power coming out, I've got a transformer simply to step it down 9 volts, is simply producing noise. So safe to say this particular inverter is not an inverter at all. Okay, inverter number 2. This is the modified sine wave inverter. A little bit more upmarket. Even has a power switch to turn it on. So let's turn it on. And let's see what the waveform looks like coming out of that. And this is what a modified sine wave looks like. So yes, technically it's going up and down as an AC voltage should, but not in the sinusoidal shape that is typical what comes out of your mains power. And I'm not sure how tolerant the Commodore 64 will be if it gets a 9 volt AC voltage that looks like that. And now to the third of our inverters. So the 12.5 volt DC coming in to our pure sine wave. Again, it's a more upmarket one, has a switch on it. So let's turn it on. We're getting power, good. Going through, and that is what a sine wave should look like. Probably still not as perfect as mains power sine wave. Actually, I will test that next. But boy, I'd love to get the AC 9 volts from a battery inverted and looking like that for the Commodore 64. I think that is what would be ideal. And yes, for comparison, let's have a look. This is in my country, 240 volts AC at 50 hertz. Plugged into a small transformer. This steps down from 240 volts to 9 volts AC. And here's what the oscilloscope shows me. Interesting, so it's still not a perfect sine wave. I don't know if that's maybe the characteristics of the transformer or something. Or maybe the quality of the mains power in my country is not perfect. But anyway, at least we know that the pure sine wave inverter produced a very similar sine wave to that, and I'd be happy if we can put that into Commodore and not damage any of our retro equipment. Just experimenting with ways to mount the 12 volt LCD monitor onto the back of a Commodore 64. This is quite elaborate. I've got a couple of these brackets here designed to just clamp. I'm not really happy with it. But interestingly, I came up with another novel idea. These little brackets that come to hold your phone on the grill, the air vents in your car. But interestingly, looking at the size, we may be onto something here. Anyway, it's just another way that we could quickly attach the necessary hardware back here with the battery and the screen. I'm going to experiment with this as well, just ways of being able to connect a screen onto the back of the Commodore 64.